All right, so now we're doing something else slightly different with stoichiometry, but it's still the same math. We are looking at what are called limiting reagents. And before you freak out or tell your teacher there's a typo, reagents are just another way of saying reactants. Just how it is. Don't know why chemists have two names for it. We're weird. All right, so before now, you have been told or you have assumed that one of your reactants was in excess. What's the word excess mean?
Extra.
Extra. So you've got extra, so you didn't have to care about it, you could ignore it. You could cross it out if you wanted to. But now, you're not going to get told. You are going to be given 2 reactant starting amounts, and you're going to have to figure out which one you've got too much of and which one you're going to run out of.
That means a lot of math.
That means a lot of math. You're going to have to do stoichiometry twice on all of these problems. All right, so what we're trying to figure out is our limiting reactant, and so if it's limited, what's it going to do?
It's running out.
It's running out. So it's what's going to cause the reaction to stop because it's run out. Because if you don't have any more of one thing, you can't keep making product. It's like if you're trying to make sandwiches and you've got enough bread for 20 sandwiches, but you've only got enough peanut butter for 5. You can't make 20 sandwiches because
doesn't work.
The peanut butter doesn't go that far. All right, so limiting reactant is whichever one your stoichiometry says will make less product, which you should have seen in your s'mores lab. You had something you ran out of, and that said how many s'mores you made. All right, so you're going to have to use more than one set of stoichiometry calculations. It'll be okay, though. It's just a little bit more.
It's just the same thing over again.
All right, so let's try a problem. All right, if I start with 25 grams of lead 2 nitrate and 15 grams of sodium iodide, I want to know how many grams of sodium nitrate I can make.
Okay, so I'm going to have 2 givens on this one. So this is a given. We're going to get a turret. And this is a given. And but I only have 1 wanted. So they're both going to go to the same place.
Right. So we're just going to set up 2 sets of tracks and do it twice. It'll be okay. All right. So where do I always put what I'm given?
In the beginning.
In the beginning. Which one do we want to start with?
I'm going to start with the first one first.
All right. Doesn't matter. You just have to do both of them.
Okay, so we're going to start with 25 grams of lead is PB, I know. Nitrate is NO3. And if you look up here, it's pretty much already doing it for you. So just figure out which one it matches. So you don't even have to crisscross your charges or anything.
Okay, and so we're going to need, what do we need next?
Okay, well, I need to change my grams to moles, so I need my molar mass, because I know 1 mole of PbNO3 is always equal to the molar mass of PbNO3.
All right, and so we add all of that together, and we get 331.22 as my molar mass. Okay. And now that we've gotten 2 moles, we're going to have to use our
molar ratio.
Mole ratio.
So we're going to sodium nitrate. I know sodium is in A, and then nitrate is NO3. So this is my wanted. And moles of PbNO3 go on the bottom. So, well, there's nothing in front of my PbNO3, so 1. And in front of this one, there's a 2.
All right, and then our last set is going to be
go into grams of sodium nitrate.
All right, and our molar mass of sodium nitrate is 85.
NaNO3. 85? Yay, nice solid number over 1 mole. Equals, so 25 times 2 times 85 on top divided by 331.22 on the bottom.
And so that makes our theoretical yield, according to our lead nitrate, 12.83 grams. All right, so now what you're going to have to do is do the exact same thing with sodium iodide. So why don't you try that one on your own? Come back in a second, and we'll see if we have the same answers.
Okay, so once you've done your math for the sodium iodide, and you might have noticed right about this point, from there to here, it all actually is the same as above. So you don't have to recalculate any of your stuff. You're only putting in new stuff at the beginning. Because you're going to the same thing. Okay, so we said that it made 8.51 grams of NaNO3.
So if I have enough lead nitrate to make 12.85 grams of sodium nitrate, and I have enough sodium iodide to make 8.51 grams of sodium nitrate, which one of those can I actually make?
Well, I can only make my lowest amount, so I can actually only make 8.51 grams of sodium nitrate.
Again, it's like our sandwiches. If you run out of peanut butter, even if you have all the bread in the world, you can't keep making sandwiches. You have to be done. All right, so which one of these is our limiting reagent then?
Okay, so my NaI is the one that made less, so that must be my limiting reagent.
All right, so now there's one more thing that we can make you calculate when it comes to limiting reagent problems, and that is how much of your excess reagent is left over. So we're going to actually have to do one more set of tracks. So we want to know how much of our excess is left over, so if sodium iodide is our limiting, what's our excess?
Okay, so our excess was the lead nitrate.
Lead nitrate. So we need to know how much lead nitrate we actually are going to be using out of our original. So we're going to start this time with 15 grams of sodium iodide as our given.
Okay, 15 grams.
Okay, and then we just do your usual stoichiometry. So why don't you pause for a second and try and set it up on your own, and we'll come back to you. All right, so because you should be really used to stoichiometry, this is why we're not taking the time to go through it with you, but it's all there. So you get all that set up, and you find out that you actually will use 16.57 grams of lead nitrate when you do this reaction.
Maybe, 3, 2.
Okay, so if I'm actually going to use 16.57 grams, and I started out with 25 grams, how do I figure out how much I have left over? Subtract. So 25 minus my 16.57, and that gets me 8.43 grams of lead nitrate left over.
8.43.
Okay. So now's a good time. Stop, try your guided practice on your own. Come back and join us later.
Yay!